So in this video, this is section 1-2 of chapter 1, types of data. Again, refer to these notes and these definitions while I'm working these problem out. All right, so section 1.2, types of data. So the first definition that you need to know, or the first two, is when you have a population and a sample, right? That's part of the process of conducting a statistical study. Values, numerical measurements for the population are referred to as parameters. So any value that is a measurement of a population, we call a parameter. Any value, any numerical measurement or value related to the sample is called a statistics. So statistics has two meanings, right? Statistics has the meaning of the field of statistics, and then we also use the word statistics to refer to numerical values or measurements for a sample, right? You hear that all the time, like what's the statistics on the death penalty or whatnot. So when somebody says that, they're talking about the sample, the values related to the sample data that we've collected. So parameter, population, right? Parameter are numerical values related to the population. Statistics is numerical values for the sample. So you got to know these two terminologies because we're going to use it throughout the entire semester. So a nice way to remember is population, parameter, sample, statistics, right? That alliteration there. So for example, here's an example of a parameter versus a statistics. A parameter would be like the proportion of all Americans who approve the president. That's a parameter. Why is it a parameter? Let's say that the actual value was like 57 people, 50% of the entire population approved the president. That would be a parameter because that 57% is referring to the population. The proportion of Americans who approve the president in a sample, that would be a statistics. So let's just say in the sample, 35% of the 1,000 people approve the president. Well, that's the statistics because that 35% is referring to the sample, right? So types of data. I'm going to go back to the notes, and here are the definitions of the types of data. We have quantitative type data, we have categorical type data. These are both for broadly speaking, that's what we're going to look at. So if you refer to this diagram, I'm going to fill out this diagram. So types of data, broadly speaking, so we're looking at data types or types of data. So broadly speaking, we have quantitative type data, right? Quantitative type data. And then we have categorical type data. Categorical type data. And quantitative type data is just numerical data. Okay, and then it breaks down further. So quantitative type data can be broken down as discrete type data and continuous quantitative. So here's a definition for those. Discrete type data are where the number of possible values is either finite or countable. And then continuous is where there's an infinitely many possible values for the type of data, for that data set. So for example, discrete would be like the number of eggs that a hen lays, right? So let's say we're collecting data and we're collecting the number of eggs each hen lays. That's discrete because it's countable. The number of eggs is countable, right? And on top of that, there's nothing in between, right? It's all whole numbers. You can't have like 1/2 eggs. You can only have whole number eggs, right? So the easy way to think about this is that you can count. You can count, can be counted. And whereas continuous, it must be measured. Now, I put quotations around these because these are kind of shortcuts only. They don't work all the time. There are exceptions, but they usually work. So if you run into a problem where it may not work, go refer to the definition. So the definition for continuous is there's infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruptions, or jumps. Now, what the heck does that mean? So, for example, an example would be like the amount of milk cow produces. So that has infinitely many possible values. Why is that? So let's just say that, actually, let's look at this example instead. That's fine. We can look at this example. So amount of milk produced by a cow, right? So, for example, we can have, let's say we're measuring in milliliters. We can have a cow that produced like 2.17 milliliters, right? The infinitely many possible value comes from there are an infinite number of values that we can get. We could get like 2.17291, right? Milliliters. So in other words, on the scale of possible values, starting with 0, right? So we can have a cow that doesn't produce 0. We can mark off like 1 milliliter, 2 milliliters, 3 milliliters, or 4 milliliters. But then we know that we can get, technically we can get any values between, like let's say from 1 to 2, we can get any values in between there. We can get like a cow that produces 1.5, or we can get a cow that produces like, 1.52173991. There's an infinite number of values that values that are possible for amount of milk produced by a cow. That's when it's continuous. And because there's an infinite amount, we got to measure it, right? This is something that we have to measure. We can't just count the amount of milk produced by a cow. We have to measure it with some kind of tool, right? Versus discrete, like the number of eggs. Let's say this spectrum here represents the number of eggs. We can only have whole numbers like 0 eggs, 1 egg, 2 eggs, 3 eggs, 4 eggs, 5 eggs, right? It's not continuous. It's countable, right? Because we can count the number of eggs, and there's not like an infinite number. You can't have like 1/2 or like 1.5 eggs produced. Does that make sense to you guys? So that's discrete versus continuous. Discrete can be counted. Continuous must be measured. All right. So on the other hand, on the other side, categorical type data, we're going to break it down to nominal versus ordinal. So we have nominal versus ordinal. And I'm going to try to simplify it. So nominal is, or ordinal is where you're ranking. It's categorical type data used for ranking. Whereas nominal is just labels. All it is labels, labels or categories, right? Let's see what the definition says. So names, labels, or categories only, right? Names, labels, or categories. And it doesn't have like a ranking to them. So what do I mean by that? Ranking. So for example, an example of ordinal would be like course grades, right? So first of all, these are category. You guys all agree that this is category? It's not numerical, right? It's not number. And if they're used to rank, right? They're used to rank, and we know that the ranking order of letter grades is that A is better than B, and that's B is better than C, and C is better than D, and D is better than F. Whereas like with nominal, like an example of nominal we have here is survey response, right? Yes, no, undecided. it's just labels. There's no order of ranking, like high to low order for yes, no, or undecided. All right. So let's go ahead and look at these examples here. So in this example, we have college data collection. So colleges, they tend to collect these type of data from you guys. So let's just say for this particular school, they collect these data, like these data from the students. So identify them as quantitative or categorical, and then from there classify each data as discrete, continuous, nominal, or ordinal. Okay, so let's go ahead and go through this one by one. Race, is that quantitative or categorical? That looks to be categorical, right? And I'm just going to put cat for short. Gender is also categorical, right? There's no numbers there. Letter grades, that is categorical. Number of units, well, that's quantitative because we're using numbers that represents count, right? So I'm just going to put quant. Income, so that's quantitative as well because that's numerical values. Height is quantitative as well, right? Because that's numerical values that represent counts. This last one's a little bit tricky. Student ID. So student ID, I'm going to say that it's categorical. So take a moment to think why it's categorical and not quantitative. Well, you might say, well, they're numbers, right? Student ID is, we use numbers for student ID. Well, it's actually categorical because those numbers are used to label a student. They don't actually have a quantitative value for those student ID, right? So in that sense, it's categorical. So another trick question would be like if in sports, jersey numbers, that's categorical as well. Those jersey numbers are used as labels. They're not used for. They don't have a quantity. It's not quantity based. There's no value based in those jersey numbers. It's just used to labels. All right, that makes sense. Okay, and now we're going to describe it as discrete, continuous, nominal, or ordinal. So for categorical type data, you can only describe it using nominal or ordinal, right? You can't. Discrete and continuous is only for numerical. So is race nominal or ordinal? So is there a ranking with race? Is one better than the other, or is it just labels? So hopefully we all said nominal, right? There's no ranking. Race is just nominal, just categories, right? Gender, is there a ranking to gender? Again, hopefully you guys all said no. So this is nominal. That's right. What about letter grades? We talked about this already. Yeah, it's a categorical type data, and there is a ranking order to it, right? A is better than B is better than C. So this is ordinal. So another example of a categorical type data that is not is ordinal would be something like, in a marathon, place in marathon, right? Place in marathon. So like if you got first place, second place, or third place. So that would be an example of an ordinal type of data. All right, so number of units completed, is that quantitative? It is quantitative, but is it continuous or discrete? Yeah, I'm going to argue that it's discrete because you can count the number of units that somebody completes, right? So let's say a student takes 5 units the first semester, so we got 5. And then they take, 10 units the next semester. Then you can count the number as it accumulates, the number of units. Income, I'm also going to say discrete because you can count money. So income is discrete. And then height, it's continuous. That's right. It's continuous because it's, again, number of units and income can be counted. But height, it's something that you got to measure. You can't just look at somebody and count the number of feet or inches they are. You got to measure it with some kind of tool, right? And then lastly, Student ID, it's categorical, so is it, it is nominal as opposed to ordinal. That's right. All right, there we go. So you got to be familiar with these classifying data. This is 1.2. So I'm going to stop the recording here. If you have any questions, again, rewatch this video or send me an email.